The Sky This Month with your host, Dave McDonald.
Welcome to The Sky This Month. I'm your host, Dave McDonald, and this show is going to comprise both November and December 2025. So maybe it's worth a watch twice, once in November and once in December. There's a lot to talk about. And one of the things that we like to mention is our partner, the McAuliffe Shepherd Discovery Center. There's a great program going on coming up on Friday night, December 5th. Okay, so you can see the information there on your screen. We are having a meeting with Circus Meeting Science. It's going to be a lot of fun, the Flying Gravity Circus, and it's going to be a ball. You can check out more details at www.starhop.com/Superstellar Fridays. But you can navigate, just get to starhop.com and you can navigate from there and find out all about it. And being the first Friday night of the month, we have the New Hampshire Astronomical Society there with their telescopes, if it's at least partially clear. And a new program that we're having, that we will be having on December 5th, is Ask the Astronomer. So you can see that we have free expert telescope guidance every Superstellar Friday, December 5th, for sure. And this is in partnership with the New Hampshire Astronomical Society. So if you have questions about your telescope, how to use it, it's in mothballs in the garage or the attic or the cellar, bring it. If you want to bring it physically, you can. Ask questions, or any other questions you have about the night sky is perfectly fine. Well, we have a meteor shower coming up in November. We have a meteor shower coming up in December. And you may be aware, there's been talk about supermoons. And we had a supermoon in October. We had a supermoon in November, earlier in November. Perhaps you got to see it. And we also have a supermoon coming up in December, December 4th. So what is a supermoon anyway? So check this out. One of the things that you should know is that the orbit of the moon around Earth, as you're looking at the diagram, you see that perigee is when the moon is closer to Earth, and apogee is when the moon is further away from Earth, and it creates this elliptical effect. So, as you know, we have a full moon every month, and it depends on if the full moon happens to happen when it's at perigee. And so this diagram here kind of illustrates that when the moon is closer, and you see the difference in kilometers there. In a moment I'll talk about miles, but you see perigee is closer to Earth, apogee is further away. And obviously, you just know this from everyday life, when things are closer to you, they appear to be larger. Same thing with astronomical objects, and particularly the moon. And so if you check this out here, you can see that when a comparison between what we call a supermoon, when the moon is at perigee, when it's full, versus a micromoon, when the moon is at apogee, when it's further away and full. And you can see the apparent difference in size illustrated there, and that a supermoon compared to a micromoon is about 14% bigger, but about 30% brighter. And so here's an illustration of, actually this is an actual photograph taken by the same guy, same equipment, during a supermoon and a micromoon. So you can see, if you were just looking up in the sky, you may not notice the difference, but if they were together, you would. But we particularly tend to notice the difference in brightness. So November 4th, I took this picture of the supermoon. I don't have a comparison picture, but I just took that with my cell phone. And so sometimes your cell phone can just be handy dandy. And I just pulled in, this is about 20x zoom on this. And I thought that came out pretty nice. So it's my supermoon picture for November. And let's talk about some of the distances here. We had the harvest moon, October 7th, and you see the distance about 225 almost 1,000 miles, which is 6% closer than the average. You see at the bottom of the screen is the average distance of 238, just about 239,000 miles. Then November 4th, 5th, when we had the Hunter's full supermoon, was 221,817 miles, which was 7.15% closer than average, comparing this to average, not the micro. And the snow moon coming up December 4th, 221,965 miles, which is just 148 miles further away. It's like from the bottom to the top of New Hampshire, basically, difference in, so essentially the November supermoon and the December supermoon are pretty much the same, except for a tiny bit closer it was in November. So that has to do with the distances and the apparent sizes. So the snow moon that's coming up December 4th is going to be 33.5 arc minutes. Now you may say, what's an arc minute? Well, arc, you can kind of think of a curvature, and you're familiar with a protractor, you're familiar with angles. There's 360 degrees around a circle, and each one of those degrees is a small slice of the circle, and each one of those degrees is divided into 60 smaller parts. And each of those 60 smaller parts is called a minute. Just like there are 60 minutes in an hour, there are 60 minutes in 1 degree, and we call it a minute of arc. So the snow moon, December 4th, is going to be 33.5 arc minutes in terms of its width, where the average moon is 31 arc minutes, which is just a tad more than a half a degree. 60 minutes in an hour, 30 minutes would be a half of a degree. So we got 31 minutes for average. And then so the difference is 2.5 arc minutes larger, or about 8% larger average compared to the supermoon that we're going to be having on December 4th. Now you saw in the earlier slide it's talked about 14% larger. Well, that's 14% larger than a micromoon when the full moon is furthest away at an apogee point. So 14 to 16% larger compared to the micromoon. So that's the difference in terms of the apparent size. And so I hope that fills you in, and so you have a little more understanding of what is going on. When you look up at the supermoon, enjoy it, take some pictures, and that's 3 in a row for 2025, but believe it or not, and you'll have to wait for the January show, but there's a supermoon coming up in January, so 4 months in a row. Hard to believe. So, hey, do you believe in aliens? Well, we're going to kind of touch on that subject in just a moment, but I want to welcome to our show Max Stewart. Welcome aboard, Max.
Thank you. Yes, wonderful to be here.
I hope you say that when we're finished. Yeah.
I'm sure I will.
I'm sure you will. Max is an educator at the McCall Shepherd Discovery Center full-time, and he has majored in astrophysics, and he is the guy that knows about these things. And so we have this interloper that's coming into our solar system from another star system far, far away. And so I'm going to turn this over to Max, and he's going to tell us about this interstellar visitor. Take it away, Max.
All right, yeah. So if any of you have been looking into astronomy As of recently, everyone is on the buzz right now about this interstellar visitor called 3I Atlas. You know, people have treated it as a huge deal at the moment, even people like Kim Kardashian talking about it on the web. But to really appreciate and understand how important this object is, I feel like there are a few things we need to establish first. And of course, the most important of those is going to be, what is a comet in the first place? So, comets are like dirty snowballs, almost. They are cold balls of rock, ice, and gas. Now, they're kind of similar to asteroids, you know, something that we're a little more familiar with, maybe here. The main difference between an asteroid and a comet, though, is what they're made out of. Comets are mostly made out of ice and a little bit of dust, compared to asteroids mostly being made out of rock. Just to give you an example, Halley's Comet, very famous in the 20th century for flying on through and giving us a glorious image in the sky, though this one that we're seeing on the screen right now is not Halley's Comet. Halley's Comet, the core of it that made all of those beautiful images, was about 95% ice, as opposed to asteroids, which are mostly made up out of rock by comparison. And it's thanks to it mostly being made out of ice that as these bodies come closer to the sun, they will begin to form these beautiful comas and tails, which we'll explain that a little bit more later on here. But one of the other main things to understand with comets is where they come from. They mostly come from these regions of the solar system called the Kuiper Belt and the Oort cloud. Now, if you're not very familiar with astronomy, you may not recognize what those are. The main belt that people tend to talk about in our solar system is what's called the asteroid belt. And the Kuiper Belt is pretty different than that, and I wouldn't blame anyone for not really knowing what it is. But we can go over that real quick over here as well. The asteroid belt is this inner belt of asteroids we can see inside the solar system between the orbit of Mars and Jupiter here, whereas the Kuiper belt is much farther out, just beyond the orbit of Neptune over here. And fun fact, that's the same spot that Pluto is within over here. It's about at 30 astronomical units, or on average, 30 times farther from the sun than the Earth is. And it's within that area we'll find a whole lot of comets. But then, of course, there is the other area we can see on this image on the right side here, this massive shell almost surrounding the solar system. And this is what's called the Oort cloud. There's still a lot that we don't understand about this section of the solar system, mostly because, you know, it is so far away. Most of it is outside the influence of our sun's heliosphere, the area that our sun can actually influence in the solar system with its magnetic field and all that crazy science stuff. We think there's around over 1 trillion bodies inside the Oort cloud, all of them leftover remnants from the creation of the solar system very early on when the sun just formed and all that violent stuff was happening. So it's these two areas that will find most of those comets. And, well, while that does kind of explain where they come from, it doesn't really explain, honestly, why comets do that whole pretty thing that we see inside the sky as they zip across with this beautiful streak of light and this spherical glow. And the process to it is a little bit complicated, but I have some explanations right over here. Like I said, comets are mostly made out of ice compared to asteroids' rock. So, as comets get closer and closer to the sun's high energy radiation and its heat will pelt the surface of those comets. And in doing so, it will begin to melt some of that ice, though not the melting that we're as familiar with. Because these comets aren't protected by the Earth's atmosphere like we are, they immediately get superheated, and they go through what's called sublimation over here, or the heat and energy from the sun is enough to sublimate certain chemicals. And that's just a way of saying that as these comets get closer to the sun, as they get superheated, they're able to melt fast enough to skip turning into a liquid and immediately turn into a gas. So it goes from a solid bit of ice to a bit of gas. Things like ice turning into water vapor, for example. And it's in that sudden switch, that sudden superheating, that gas plumes will be created on the outside of these comets. And in doing so, it'll kind of explode out these materials, the bits of dust left over from those dirty snowballs, and that's what produces a lot of these beautiful things we associate with comets. The coma is this area right outside the core of the comet right here, and as the coma and the comet travel through the solar system, it'll leave remnants going backward, the first of which being what's called the ion tail, sometimes also called the gas tail. That is bits of those gas that exploded outward and then got supercharged by the sun, becoming ionized. And in getting reflected from the sun, they'll produce this beautiful glow, that blue streak we associate. But there's another type of tail as well. Those bits of leftover dust that were a little too heavy to get pushed by the sun's energy and solar winds. Those form what's called the dust tail, which will be visible on the side of a comet right over in this area here. So as the comet moves along, it will have this ion tail, this gas tail going out from behind it, and this dust tail going off to the side that show where exactly it's coming from. Now, that doesn't really answer why comets are important in the first place, and the biggest thing to take away from them is they're like time capsules of sorts. Comets are leftover remnants of the early solar system, because they were created around the same time that all the planets were. So, because of that, by studying them, we can understand what the early solar system looked like. It's a treat to see comets coming on through because they orbit very far out from the solar system over the course of a few hundred years. So by doing that and by studying them, we can understand what the early solar system looked like. We also think comets are important because they may have transported these volatile materials, things that can sublimate, like water, for example, frozen in the form of ice, and carbon dioxide, frozen to form dry ice. So with comets coming on in through the solar system, spreading out these materials, and sometimes colliding with planets, they can supply these special materials. And, of course, comets are important because they're just so pretty. Who doesn't like looking up at comets in the sky with those beautiful streaks they got? But those are just regular comets, so that brings me to the next idea. Why is 3I Atlas so special here? It's special mostly because it's the third confirmed interstellar object over here. That means that it is the third thing that we have confirmed to travel into our solar system from a point outside of it. There were two other objects we've been able to confirm. The first back in 2017, its name was Oumuamua, though the pronunciation on that may be a little incorrect, and also Borisov back in 2019. Those were two very important objects, but we didn't get the chance to study them too much because they zipped on through the solar system real quick. So, we've been able to confirm that 3I Atlas is an interstellar comet for two primary reasons, but a few other things as well. The main things are it's mostly made out of very different stuff from the comets we've been able to find in our solar system. It has a lot of nickel inside of it compared to the iron we tend to find in a lot of comets. There's usually an equal ratio between the two, but 3I Atlas has more nickel than it does iron, and 3I Atlas is moving way too fast to have come from inside our solar system. It's moving at almost double the speed the Earth does around the sun at about 37 miles per second. In total, I believe that's going to come out to be around 134,000 miles per hour. So it is much, much quicker than the Earth, and because of that, we don't think it came from the solar system. And 3I Atlas is also special because it'll provide us a model to understand what other solar systems could have looked like very early on. Like I said, comets are time capsules. They serve as a way to understand the past. So if we can study 3I Atlas, we can understand what other comets may have looked like. And one of the main things that sparked a lot of controversy with 3I Atlas was the fact that it came from nearly the same area as the infamous WOW signal, which was a very famous radio signal that was observed by the Ohio State University radio telescope, the Big Ear, back in 1977. It's something that we haven't been able to find anywhere else in the universe, and we haven't found a reasonable explanation for where this odd radio signal came from. So the fact that 3I Atlas and this signal came from near the same spots is a little weird, to say the least. And that brings me to the main thing that everyone is talking about with 3i Atlas lately. Is it some kind of alien technology? Now, there's a lot of people as of recent that have been pointing this out. Some of the most famous are, first of all, Dr. Avi Loeb, who is a very famous Harvard astrophysicist who also did work on that first interstellar comet, Oumuamua, and also Dr. John Brandenburg, who's another very famous plasma physicist. These two have been talking about 3i Atlas for quite some time at this point, posting on social media, going on different interviews, bringing up all the different reasons that it could be some kind of alien tech. And they did provide a lot of good reasons why it could be, though not directly pointing to alien technology, instead to some of the anomalies within 3i Atlas, and I have some of those listed right here. I already just went over the movement speed, how fast it was going through our solar system, as well as what it was made out of, but there's a few other elements as well that make it a little unique. Mostly just how big it is. It is, 3i Atlas, about 1 million times larger than Oumuamua, that first interstellar visitor, and about 1,000 times larger than Borisov, so it's very odd for a comet to be that big. Not only that, it is at a very even level with our solar system. If our solar system is treated as a plane, or almost like a sheet of paper of sorts, it is odd for a comet to go almost head-on aligned with this plane, and 3i Atlas is nearly lined up with it perfectly, which a lot of scientists find very odd. Not only that, as 3i Atlas got close to what's called the perihelion, or its closest point to the sun, instead of shining with the same light that the sun did, it shined very blue instead, which we didn't expect, and we still don't really understand why. There's a few other reasons as well, primarily how it was able to intercept planets like Venus, Mars, and Jupiter quite easily, as well as the fact, and this is what stoked a lot of conspiracies, that as it reached its closest point to the sun, it was on the opposite side from the Earth, so we didn't get the chance to see it. And that led a lot of people to think that it was trying to avoid us in some sense. But we're not going to always be able to not see 3i Atlas. We'll actually be able to see it for quite some time moving ahead here. And if you're curious, this image I have on the side here, that is where 3i Atlas came into the solar system. This white line here represents as how it was moving along, going through, first doing a flyby of Mars, a little bit beyond the Earth, and then going out to Jupiter in the outer orbit. And this image on the bottom is the same as well, one that I was able to simulate on November 4th. So, speaking of that though, I'm not going to try to explain whether or not 3i Atlas is alien technology. I don't have the qualifications for that. Instead, we can just appreciate the fact that it's really unique and we can try to find it in the sky. So, 3i Atlas, now that it has passed by that perihelion point, it will be visible to us. Not with the naked eye though, we'll need something a little bit better than that. It's going to be within the constellations of Virgo and Leo primarily, starting in Virgo, right next to one of its brighter stars called Spica, here in November. It's supposed to rise up above the horizon about 2 hours before sunset, and like I said, it won't be visible with the naked eye. You'll need a telescope, unfortunately not just binoculars, but a full telescope with about an 8 to 11 inch lens on it, because it will be quite dim compared to everything else we can see here. But there's a whole lot of other information that we could talk about 3i Atlas. I encourage everyone to do their research on it, because while it's fun to make conspiracies about it, it's also good to be educated and know that while it's fun to think about aliens, it could just be some rock out there.
And that's what I think.
Mm-hmm. Yes, that's my personal opinion. That is my opinion as well.
It's a big rock.
Yeah.
Going very fast. It's
yes.
a speedy little rock.
Oh, yes. Of course, of course.
Hey, Max, thanks so much.
Of course.
For bringing us up to date with 3i Atlas. It's fun to talk about, and maybe we'll find out some more science related to it as we have more investigations going on, and I'm sure there are telescopes that will be trained on it and spectroscopes, and we'll learn as much as we can.
Mm-hmm. That's the goal, at least.
And see what life is like outside of our solar system, perhaps. Again, Max, thanks so much. And speaking of being able to see things in the night sky, we're going to take a moment and look about what is available in the night sky from your own backyard. Hey, I really hope you enjoyed that chat with Max. Very knowledgeable about this three-eye atlas. A very, very fascinating object to keep your eye on as best as you can. But as Max says, you need a telescope, decent-sized telescope, to actually see it. But I'm sure it'll be on the news. So we're looking at the night sky. This happens to be an image for 9:30 on December 4th, and I chose December 4th, because that's the night of the full moon, the cold moon, the snow moon, which is also a supermoon. And you can see that up in the sky right here. It's in the constellation, again, this is December 4th, but the sky that you see is available in November through December. The sky changes about 4 minutes every night. So the sky is going to be coming up later towards the beginning of November. It's going to be coming up earlier towards later in December. But these constellations are available in the night sky for both November and December, just maybe slightly different times. This happens to be December 4th. And you can see the moon, the full moon, is in the constellation of Taurus, the bull. These represent the horns of the bull. The face of the bull is called the Hyades. It's kind of a V shape, and if you were to have binoculars, you'd see thousands of stars there. It's called the Hyades. And an object that's very familiar to all of us is the Pleiades star cluster, which kind of looks like a tiny dipper, very easy to spot with the unaided eye. Some people refer to it as the Seven Sisters. So these days, due to light pollution and air pollution, most people only get to see 6 of the 7 sisters. But I hear out west in Arizona, New Mexico, people see more than 7, so good for them. Keep in mind that the moon does move. This is December 4th, and as each day continues, the moon is going to be moving about 13 degrees towards the east. Then we have Jupiter. This is the planet that is the biggest in our solar system. You can actually fit 11 planet Earths across the face of Jupiter. And this is the constellation of the twins. This is Gemini, the twins, the 2 twin stars, Castor and Pollux. Pollux is labeled here for you. This one is Castor. And those are the twin stars, and that's where we find Jupiter for November and December. And then everybody's favorite constellation in the winter, Orion the Hunter. And Orion the Hunter is famous for the 3 belt stars, which I love to say their names. This one is Al-Natak, this one's Al-Nalam, and this is Mintaka. And Mintaka actually means belt in Arabic. And hanging below the belt is the Orion Nebula, which you can just barely make out with the unaided eye. You can see a little fuzziness there. The upper left star, as you look at Orion, Betelgeuse, don't say it 3 times fast, but is a red star, a very bright star. And we know that that's going to explode someday. And the interesting thing is maybe it already has, and we just don't know about it yet because it's 500 plus or minus light years away. So if we go to the next slide, how does this look? Can you figure it out? Because obviously in your night sky, you don't get to have the lines up there. You find Orion up in the sky, I think easily enough, and the belt stars right here. And again, on December 4th, easy enough to find the moon. But the bright star Aldebaran is an orange star, and again, it represents the eye of the bull, and this is the face. The Hyades is the face of the bull. And then the planet Jupiter shining very bright at a negative 2.3. The beginning of the month, and negative 2.5, it's going to be shining brighter as time goes on. And that's in the constellation of Gemini, the twins. So to add a couple other constellations to the mix for you to find and enjoy, the next slide, we just threw in the artwork. So Orion the Hunter here, defending himself from the charging Taurus the bull. We have the twins as mentioned, and Orion has hunting dogs. And if we take the 3 stars in Orion's belt and follow them downwards, we come to the brightest star in the night sky in either hemisphere, Sirius, a magnitude in negative 1.44 for Sirius. And then we have Procyon, the smaller hunting dog. Procyon is a very bright star that is just to the left as you look at Orion. Excuse me. And then in between Procyon and Sirius, faint stars, but if you're really interested, get yourself a star map and a dark night, which is not going to be December 4th, and see if you can find the stars that go with Monoceros. There's a unicorn in the sky. Who knew? So lots to look up in the night sky. A couple of meteor showers coming up. In November, we have the Leonid meteor shower, November 17th and 18th. And then in December, 13th and 14th, we have the Geminid meteor shower. And the Geminids are probably the most active and the best meteor shower of the year. It's not the most popular because in December, the middle of December, it's cold. But bundle up, get out your lawn chair again, get some hot chocolate, sleeping bag and stuff, because the Geminid meteors can boast up to 120 meteors an hour. It's called its Z rate. And so Leonid meteor shower in November, Geminid meteor shower in December. You've got the supermoon coming up December 4th. And don't forget the winter solstice, December 21st, 10:03 a.m. is when the sun is going to hit its lowest point. It's going to hit the Tropic of Capricorn, and that imaginary line that's on your globe, the sun is going to just touch and bounce off the Tropic of Capricorn and then head north again towards the summer solstice, which we all can look forward to next June. So that's a little bit about what's going on in the night sky. I hope that you enjoyed the show. I'm Dave McDonald. This is November and December, and we'll see you again in the new year. Keep looking up.